how come we have things such as H2O, such as carbon dioxide, such as sodium chloride, and such as Na2SO4, right? No, yeah, Na2SO4. How come we have things like this, right? How do these bonds form? Is anyone who knows how does a bond form? Like, how come we have bond formation? Or maybe, what do you think is a bond? Or how can you describe a bond?
So can it be described as a combination of two or more items or something like that?
Two or more items. That's a very, very good starting point. So you understand that a bond is when you have two or more things that are, joined together. Essentially, two or more elements that are joined together. And yes, that is true. So a bond is two or more elements that are joined together. Okay. So for us to have a bond, it's when we have two or more elements that are joined together. Now, another thing to understand in terms of bonds is that how do they form? Ne? Take an example of you, ne? But I don't encourage this, but you have to understand that, okay, let's say for you to have a friend, ne? For you to have a friend, you must go out there and socialize. You understand? You must meet different people. You must bump into different people for you to have like a friendship and and yeah, some other stuff, but usually friendship, you meet other people. So even bonds, same thing. For a bond to be formed, right? For a bond to form, particles need to collide. Particles, they need to collide. So it means they must bump into each other. Okay? And it's essential to understand this because in grade 12, you'll be talking about the collision theory. So you will understand further how does that happen. But right now, you just need to understand that for them to form a bond, they need to collide with each other. So that means if here a certain hydrogen atom and another certain hydrogen atom, they are busy just wandering around. They meet an oxygen atom. What do they do? If they bump into each other, right, and then they also bump into each other there, right? If they happen to be two of them that are attached to an oxygen molecule, then you have H2O, which is your common water. So as you can see, for them to form that water, they had to collide first, right? Same thing with carbon, and the others. Then, if I have carbon, right, and then I have oxygen, if they bump into each other, carbon bumps into these two, right? These two there. What do they do there? They form a certain compound, and that compound we call it CO2, which is your carbon dioxide. Okay, so that is what is happening there. That is what is happening. So it's important to remember that a from the discussion of atoms in grade 10, right? We said each element has a different type of atom, right? Each element consists of the same type of atom. So elements are different from each other because they have different types of atoms. For example, an element of hydrogen an element of hydrogen has a nucleus with one proton and one electron outside. while in sodium, for sodium, which is 1123, it has how many protons? It has about 11 protons in the nucleus, right? 11 protons in the nucleus. So there have to be a lot of protons in the nucleus there. Then outside, it's gonna have 11 electrons. So this will be the electrons there, as you can see. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then the last one will also be outside, which is the 11th one. So it's gonna have 11 electrons and 11 protons. That is sodium there. Okay, that is sodium, and then that is hydrogen there. So that tells you that the elements have different types of atoms. Okay, but when we say hydrogen, we mean that this is a substance that is consisting of atoms that have only one proton and one electron. Okay, so if that is a hydrogen atom, hydrogen element, is going to be having a lot of atoms of hydrogen that are all the same. And if it's a element of sodium, it's going to be having these. Okay, I actually want to show you that, remember, sodium is a metal. I want to show you that sodium is it can actually be cut with like a knife. Sodium, pure sodium, not sodium chloride. Pure sodium is a metal. I want to show you how that metal looks like. So let me just see if we can quickly go to the web here and find us a nice pictures of sodium, or possibly even some videos, so we understand what is an element when you say sodium. So let's say sodium element. Oh my goodness, sorry guys, now and again I have to prove that all this knowledge that I have is because I'm not a robot. So let's see, crossroads. Okay, yo. Okay, sure. I think the more I'm proving I'm not a robot, the less they are convinced. Yo. Does this count as a motorcycle? This thing is very, very tricky. Yo guys, please help. I don't understand. How do I pass from this thing? What? Good people, did you hear what they said there? Please assist Miss Uri. Can you hear anything there? Hey, Mr. Alex, are you able to hear anything, man? I can't hear anything. I'm trying. What? Yo. No, you know what? Actually, guys, tough luck. I wanted to show you this, but it's really guys, it's really giving me trouble there. It's telling me stuff I can't understand. Okay, but then it's fine, guys. Just understand. I know you know what are elements. Okay, so those are elements. And then now, when these two atoms, if they bond to each other, that means this one its energy levels must overlap with the energy levels of this one. Once we have something like this, that's when we say we have a bond. Okay, that's when we say we have a bond. Now, whether it's gonna be a double bond, a single bond, and the likes, it's gonna depend on the Lewis diagram is gonna tell you. Remember, you did Lewis diagrams, but we're gonna do them again this year. But we're gonna go to the basics of this graph that represents how bonds occur. So the graph that we work with is this one here. That really explains, or actually what is going on there. We're gonna take two atoms. Think of as this is atom A, and then think of this as atom B. Now these two atoms, right, this one is gonna have a positive nucleus. This is also gonna have a positive nucleus. So we have two atoms, A and B. Both of them are gonna have a positive nucleus. Then outside they're gonna have electrons. Now a question will be, how can these two things form a bond? How is it possible that things that have positive charges and negative charges, both of them have positive and negative charges, how come they form a bond? You understand? So how does it happen? First of all, for the fact that there is a positive here in the nucleus, it's gonna be attracting this negative here, which is the electrons. That positive charge on one atom is gonna be attracting the electrons on the other atom. That's how it works there. So at the same time though, the very same positive charge is gonna be repelling, right? It's gonna be repelling the other nucleus. So these ones is gonna be repulsion here. The positive and the positives are gonna be repelling each other, while the negative and the negative, they are also going to be repelling each other. That is whenever you have two atoms that are at a certain distance from each other. You understand? So if there is a force of repulsion and there is a force of attraction, as we said that here, there is a force of attraction. If we have such, right, how can they form a bond? Because they are repelling each other at the same time they are attracting each other. Well, what happens is going to be explained by this diagram. Right, it's going to be explained by this diagram. This diagram, when you draw it all the time, you're going to draw it like this. This is how you're going to draw it there. What will be on the x-axis? Well, on the x-axis is going to be energy. It's going to be energy. And then here it's going to be distance between the nuclei. Distance between the nuclei. On the nuclei. Yeah. So that means is the distance between this positive nucleus and that positive nucleus. So whatever I was explaining here, I would like to give you that in terms of a diagram. I do have what you call some nice illustration of that, you know, that we can use. So we're using hydrogen, two hydrogen atoms that are approaching each other, and this is what we have. So let's understand that because these things are approaching each other, right, as they move closer, there is a repulsive force. There's a repulsive force which is between the electrons of the atoms, meaning the electrons are repelling each other, since they are like charges and like charges repel. And every atom is going to have negative charges, so those negative charges are going to be repelling each other. And they are also going to be an attractive force, which means this positive, as much as these two are fighting. This is more like you have one couple here. You have one couple, and then you have another couple. In this couple, this is the man, this is the woman, right? So this is the man of the house, this is the lady of the house, and then this is another family there, you see. So the ladies, they are fighting each other. You see, the ladies, they don't like each other, they are fighting each other. But it doesn't stop the men from liking the lady there. And it doesn't stop this man from liking that lady there. So that is why we have attractive forces between this man and that lady. And then this guy also is gonna be attracted by that lady there, you see. So it's more of like these people, they married the wrong people. So this is what is happening in terms of electrons. They're busy being attractive to the protons. Protons wants to pull them closer, while the electrons themselves, they are repelling each other, and the protons themselves, they are repelling each other. That means even this guy is not liking that guy. They don't like each other. They don't see eye to eye. They are just neighbors. When you are just neighbors, you are just forced to like each other. So that's what is happening. So they find out that we actually married the wrong people here. I should have been with that. So that is why there is an attraction force between the protons and the electrons, between the two atoms. And then there are some repulsion forces between the positively charged nuclei, meaning the men are also repelling each other, the ladies are repelling each other, but then the electrons and the protons, they are attracting each other. All of these three forces, they exist as long as there are two atoms, as long as there are two atoms at a certain distant from each other or closer to one another. There will always be those three forces. Okay. Yes, you can ask Mr. Alex.
So let's say you have three women in one house.
Actually, understand that the electrons there, even though we're showing only one, it's actually not one. I mean, look, you saw the atom for sodium, it has so many electrons. You see, it has so many electrons. So all of those electrons there, they will be attracting this positive. You see, all of them, they'll be attracting the positive, while this positive is also going to be attracted to that one smaller nyana electron there. You see, yeah, guys, that's what is going to be happening. And then these things, these forces, they are there, they exist. So as a checkpoint, what forces do we have when you have two atoms close to one another? What forces do we have? We have attractive forces between what? Attractive forces between between the positive and the negative. Okay, sorry for that. So we have attractive forces between, let me just be writing also. The only attraction forces is between what? This is between positive and negative. But the negative is what? Is the electrons. Yes, it's the electrons. While the positive is the what? Is the protons. Perfect. Those are the ones that are attracting. And then our repulsion forces, they exist between what and what?
Proton and
two allied charges, like positive and positive, negative and negative.
Positive and positive. So it means it's protons and protons.
Yes, sir.
Great. So between protons and protons of this atom and protons of that atom, they are repelling each other, while electrons of this atom and electrons of the other one, they are repelling each other. They are also repelling each other. So one might say, because there is a lot of things going on here, Kanti, which force is actually gonna win here? Because we said they make a bond. Kanti, how do they make a bond? Then we come to that now and say, okay, so we explain what happens, right, using this diagram, so that we understand how does a bond actually form. So I started liking physics a lot when I was in grade 11 due to my teacher. And I think I liked the way he explained this thing, because I never forgot it even to this day. This thing. So beautiful. So beautiful. So let's start. Now we have many points. So I'm just gonna call this point A, B, C, and then D. Okay. So we're gonna explain what is happening at A, then go along like that. Because you actually, he always told us that, you know, guys, if you chose to do chemistry, one thing you must know how to do is to explain. You don't have a chemist who doesn't know how to explain. So I took that by heart, and then I made sure that I used to explain everything that's going on, so that you explain anything that you see in this world. Now let's understand there, right? To say what we are imagining there is that we have two hydrogen atoms. Okay, this is a hydrogen atom here, and this is another one. So let me just say H here to say this is a hydrogen atom, and then this is another hydrogen atom, as you can see them. Now, because we have both of them, we do know that there will be repulsion forces between the protons and repulsion forces between the electrons, and then attraction force between the protons and the electrons of both. You understand? So what is going to happen, right? So we then start here to say, when they are far away, let me just use a yellow one. When the atoms are far from each other, the dominant, the dominant force is the force of attraction. Okay, as they are far away from each other, the dominant force is the force of attraction. That means actually these things, both of them, right, the forces of attraction are actually much stronger as compared to the forces of repulsion. You see, when they are far away from each other, by nature, the force of attraction becomes stronger, so that these things can come closer to one another. Okay, that is what is happening at A. That means that the forces of repulsion are weaker compared to force of attraction. That is what is happening there. Are we okay with what is happening at A there?
Yes, sir.
Yes, sir.
Great. So this is something you can explain, when if someone shows you this graph and they're saying, hey, what is happening there when these things are far? You just tell them there, what you're not able to see with your naked eyes is that these atoms are far away from each other, mean that you can see, but then the forces of attraction are dominant as compared to the forces of repulsion. So they are dominant over the forces of repulsion. So they are stronger in a way. Now, at B, what is happening, right? So due to the forces of attraction that we said they were dominant, they are bringing these two things together. You understand? So that is why at B, the atoms start moving closer to one another. Due to forces of attraction. So as you can see there at B, they are now closer. They are moving closer and closer because the nucleus of this one is attracting the electrons of the other one. You understand? That is what is happening. So that brings them closer to one another. And then now what is happening here at C, right? Now at C, they are as closest as they can get. We can say at C, they are as closest as they can get. Okay, which means they have formed a bond. We actually say they are bonded together. They are now bonded. They are bonded together. You see, that is what is happening at C. And remember, from A to C there, I've been talking about distance and the force of attraction and repulsion. You understand? So here you have to understand that at C, the forces of attraction and repulsion, now what is happening is that the forces of repulsion starts to dominate. Forces of repulsion, they start to dominate. Okay, because these things are closer to one another now. You see the nucleus of this one, if you can zoom closer here, you can see that now what is happening, the nucleus of this and the nucleus of that, they are too much close to one another, so they start repelling each other. The forces of repulsion, they start to repel, such that at point D, these forces of repulsion, they become so dominant that they start now repelling the what you call the atoms. That means the bond is breaking. Here the bond is now breaking due to that, due to dominant forces of repulsion. Right? You can ask there, someone raised the hand.
So what about the energy?
The
y-axis?
Yeah, we are going to talk about the energy after. So right now I just wanted you to understand in terms of the distance between them and what is happening to the forces. Are we okay with the distance and forces? A, the forces of attraction are dominant. B, the atoms are starting to get closer to one another due to the forces of attraction. And then at C, they are as closest as they can be, meaning that they have formed a bond, right? And due to them forming a bond, the forces of repulsion start to become dominant. Even at D, the force of repulsion have started to dominate, such that now they pull them away from each other. Is this okay?
Yes, sir.
Yes, sir.
Okay, perfect then. So that is what is happening. Now let's talk energy, right? Good, Mr. Tao. Let's talk energy now. What is happening in terms of the energy? Now, in terms of energy, when they are far away from each other here, meaning at A, the energy between them is high. So here we can add energy to say the energy between them is high, or energy that they have is high. So the energy that they each have is high. The energy is high, right? Because you have to understand, why would I say here energy is high and then are we saying that here energy is low? Yes, energy is low there, right? Because here energy is higher as compared here, it's further negative, and get so energy is very much low. Okay, so at B, what about at B? The energy, they start to lose energy. They start to lose energy. That is at B there. They start to lose energy. What about at C? Right? At C, they have lost the maximum amount of energy they can lose. So they have lost maximum amount of energy. We can say they have zero energy now. right? In other words, we say they are stable. They are stable. Okay, they are stable. Then what about at D? At D now, their energy shoots high. So at D, the energy increases drastically. Their energy increases drastically, as you can see there. Yes, Mr. Alex.
So why does the energy suddenly increase?
Why does the energy suddenly increase? This is because they were repelling each other. So as they are repelling each other now, they start to move away from each other. And let's remember that when they were away from each other, do you remember that we said they had high energy when they are away from each other? So here they start to have high energy because they are away from each other. They are being pulled away by the forces of repulsion. So that means they're going to gain energy again, So let me explain this in terms of people so that it makes much more sense. I like it in terms of people. Now here you are, right? Think of it as, here you are, this is, this is one of you there and one of you. So now you find that you are far away from each other, right? Now the reality is that when you are far away from each other, you tend to be active and doing a lot of things that you like. So we can say you have a lot of energy. I mean, right now, good people, when you are single, you are not restricted to anything. You can do whatever that you want. You can go out, you can come out and come back at time that you want. If you are a person who likes to chow money, you chow as much as you want. You like food, you eat as much as you want. That means you have a lot of energy. But let's say now you are getting closer to someone, because now there's this guy or there's this girl that you've been, noticing from afar. Now what happens is that when you start to interact, you are starting to interact now, getting closer to one another. What happens, if you used to come back at home at 10, now you're coming back at home at 8, so that you can get time to chat with your person before they sleep. You understand? You have to catch them at the right time, because if you keep on doing your thing of 10 p.m., they will just say they've slept. You understand? So you start restricting your movements. You start to lose a bit of energy, right? And then you're gonna keep on doing this. Now you go on a date, right? And then everything, and then you end up at C here, whereby both of you now are stable. When we mean that you are stable, you are no more doing a lot of things. You cut off a lot of friends, especially those single friends. You cut them off, right? You cut off things that you like to do. If you like to play FIFA, what, now you're no longer doing that. You are stable. Now we say you are in a relationship. You have formed a bond, right? Now that you have formed a bond and you have lost maximum amount of energy, you are stable. But the reality is that a relationship, good people, is not easy. You understand? It's not easy. There will be complications. You start to, I feel like, hi, but this guy is too much, actually. You know what boys say? This girl is clingy. They like to use this word. They like to use this word, clingy. Yeah? How is she clingy when you are the one who wanted her in the first place? But they start saying those things, understand? I can't do anything that I wanted now. They start to be these forces of repulsion that are developing inside you in the relationship. Then what happens? You start, pulling away from each other. You are starting to, I like this song by Amanda Black. She says what? Drifting away. You should listen to that song. She talks about drifting away. She understood the concept very well, that because you are in a relation and you are starting to find out that actually Tabo, he doesn't know how to make jokes, this guy. Then you start to feel like, I know, man, I made the wrong choice. And then you pull away from each other, you see. And then each of you starts getting back their freedom again. And that's why you gain a lot of energy. So good people, that explains this graph. That's exactly how atoms behave, right? Because if we can explain life using maths and chemistry, you understand that life makes sense. So this is exactly what is happening. It's just two things that were far away from each other, now they were just, because you see someone from afar, you get attracted, and looks, you get attracted, and then they start to move closer to one another, releasing energy until they are at the lowest energy, which means they are stable, and then they start to regain that energy due to forces of repulsion, and then that's why we see the situation at D. That is the end of the story, guys. Is there anyone who doesn't understand this graph? Are we good? Are we understanding this? You can explain.
Is there a specific name for this graph? Or is there specific like title for this graph?
It's called a potential energy graph.
According to say.
Yes. Is a potential energy graph. So it describes the energy changes that are happening between atoms, right? Yes, Mr. Alex.
So what happens after D?
Right. They're gonna meet other people, say, right? Same as those atoms are gonna meet other atoms and form other bonds, you see. Right. And then now you have to know how to then interpret it in terms of description, just as I has described. Don't use the term of relationships and stuff, guys. You must use. That's why I wanted you to understand it in terms of the distance, and then in terms of the forces, and then in terms of energy. When you explain this graph, talk about the distance, talk about the forces, and then talk about the energy. Do not talk about some of the other stuff I was talking about today. Now you must focus on these ones. Now, when you are interpreting it, the distance between here and there, right? When you are reading on your x-axis, because your x-axis represents the distance, so whatever value you're gonna find here, whatever value, if you find that is 20 here, then maybe it's 40 and stuff. This means that this distance here, we call it the what do we call it? Is what? Bond length is the bond length. Almost forgot that. It's called the bond length, good people, okay? So it will mean that it's the bond length here is 20. They like to use picometers. As the measuring unit. So if it is 20 there, you say the bond length is 20 picometers, okay? 20 picometers. Just check whatever unit that they are using. Then here, when you read the value here, right? The value here, obviously energy is measured in joules, or it could be in kilojoules. Now, if you find that here it is 80, this one here is called the bond energy. Okay, it's called the bond energy. So when you read there, they ask you which one is the bond energy. You're gonna tell them that it is 80 kilojoules. It's negative 80 kilojoules, by the way, because these are negative values. So you'd put negative 80 kilojoules, and that negative, it just indicates to us how much energy was lost. You understand? Because when a bond is formed, energy is released. You have to understand that. You don't gain energy. You don't form a bond by gaining energy. You form a bond by releasing energy. You see? Same way as we're saying your freedom becomes limited. Okay. So is that okay, guys? Is that clear?
Yes, sir.
Yeah, thank you, sir. No, yeah, that's fine.
It's clear.
Yes, sir.
Okay, great. Yeah, so that is what is happening there. So if you understand that, good people, then now you know how does a bond form. Okay, so then from there, you will have to understand how to draw what you call Lewis dot diagrams. Let's see. You I don't know if you have a periodic table with you there, but let me just have my own periodic table there that I remember. Remember, you must know the periodic table, but you will be given, by the way. So yes.
I think limited page.
Oh, okay. Great. Okay, so a periodic table is what? Is a hey libe, right? Say libe book nof ni nam al sips clar right. Okay, so this will be how your periodic table will be looking like, right? Let me just make this. It's not the best of all, guys, but you know what? I tried my best here. So this is how it will look like when you look at it in your periodic table there, right? So what I need you to do, right? Because this is the most important part of it all. You must know that the valency, we have what you call a valency. The valency of all these ones in here is +1. The valency of all these ones here is +2. The valency of all these ones in here, boron and aluminum, is +3. For carbon and silicon, it's ±4. And then for neon and for nitrogen and phosphorus, it's a -3. For oxygen and sulfur, it's -2. For fluorine and chlorine, is -1. And then here it is 0. This is the valency. You should draw. You see this thing? You should write it. You should write it when you, on your periodic table, even before you write the exam, because it's gonna assist. Now, how is it gonna assist us? It's gonna assist us to understand or why if I can have hydrogen, right? Then I have chlorine, right? And get a hydrogen is +1, and chlorine is also what? It's also is -1. So when they bond together, right, what they form is HCl. What happened there is that this one, it comes here, and then this one, it comes there. So therefore they form HCl. We don't have to write H1Cl1. You see that? That is why you have HCl. Let me show you carbon dioxide. I get we have CO2. Let's no, actually not carbon dioxide. Let's say just that they are limited, which you can form here. But let's say lithium oxide. We do have lithium oxide. Why do we have it as LiO2? Why don't we write it as LiO? Because it's lithium and oxygen, right? Why don't we just say Leo? Good people, you have to understand that when they join those things, lithium is 1+, and then oxygen is 2-. You see, even I got it wrong there. 2, you put it down here, 1, you put it down there. So lithium oxide is Li2O. This is lithium oxide. This is lithium oxide. Okay, what about magnesium oxide? How do we write magnesium oxide? Well, here's magnesium. It is 2+, isn't it? You can say it's 2+ or +2, it's whichever way. And then oxygen is 2-. So what happens is that this 2 is gonna come here, that 2 is gonna come there. So you're gonna have Mg2O2. But because 2 and 2 are the same, we just divide by 2 throughout so that we have MgO. So if the numbers are the same, we just drop them and then just write the letters. So it becomes magnesium oxide. That's where magnesium oxide it comes from. Okay. Why do we have H2O? That's a beautiful one. Look at hydrogen. Hydrogen is +1. And get, look at oxygen. Oxygen is 2-. So what happens? The 2 comes here, and then the 1 that is here comes there. So you have what? H2O. That's why when hydrogen and oxygen combine, they form H2O. Okay, What else? Maybe we want beryllium chloride. How will they look like? Beryllium is 2 plus, chlorine is 1 minus. So this 1 goes here, the 2 goes there. So you have BeCl2. That is beryllium chloride. Good people, this is called writing the formula of compounds, and that's how you know how to write them. Okay, you just have to check the valency of them. Okay, last one I can do for you, calcium chloride. Let's say we need to write calcium chloride. Well, for calcium chloride, calcium, when you check, is 2 plus, chlorine is 1 minus. So the 1 goes here, the 2 goes there. It's like cross multiplication. So you have CaCl2. This is calcium chloride. Is there a question? Okay, so that is how we get calcium chloride, and that is how you can know other compounds, good people. Okay, but then my intention was actually not to teach you that, because remember, it was already taught in grade 10. So I'm assuming you already know it, but if you didn't, then now you know it. Now, what is actually very important about this is apart from valency, we have what you call valence electrons. We have valency, we have valence electrons. Now, in terms of valence electrons, in this group, this is called group 1. In this group, all of them, they have 1 valence electron. In this group, all of them have 2 valence electrons. In this group, all of them have 3 valence electrons. In this group, all of them have 4 valence electrons. In this group, all of them have 5 valence electrons. In this group, all of them have 6 valence electrons. In this group, all of them have 7 valence electrons. In this group, all of them have 8 valence electrons. So when you count them, is 1, 2, 3, 4, 5, 6, 7, 8. So the group number will tell you the amount of valence electrons you have. But I know there is a missing group here. It's a group, there are many groups that are missing here. They are off transition metals. We don't count them. Okay, we don't count those transition metals. We only focus on these, that, those, and that. Okay, understand? So on your periodic table, this part here, you just forget about it in terms of valence electrons. Okay, so you have 1 valence electron in here, 2 of them there, 3 of them there, and the likes. Now, how does the valence electron help us, or knowing the valence electrons, how does it help you? Because right now, if I say to you, draw for me the Lewis dot diagram, maybe for hydrogen. For hydrogen, you draw H, then you represent the valence electrons with a dot. You can even write it at the top there, whichever way you want. If I say for you, draw for me the valence, the Lewis dot diagram for beryllium, it's going to be how many valence electrons? 2. So it's gonna be 1 and 2. By the way, you are also allowed to use X's if you want. But you can't use here an X, then you use a dot. You have to be consistent. And then silicon or carbon, right? Carbon has how many valence electrons? It has 4. So you say 1, 2, 3, 4. That is for carbon. What about nitrogen? It has 5 valence electrons. So when you draw for nitrogen, you say 1, 2, 3, 4, 5. That is it there. What about oxygen? When you draw for oxygen, you can say 1, 2, 3, 4, 5, 6. That is the valence electrons for oxygen. What about fluorine? For fluorine there, you will say 1, 2, 3, 4, 5, 6, 7. Okay? And then what about for neon? For neon, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Good people, what about for helium? For helium, it's simply going to be 1, 2. Okay, you are not gonna say 8. Helium has only 2. So the exception there is an exception that this one has only 2 valence electrons. It doesn't have 8, but the rest of them have 8, such as argon there. Okay, good people, are we clear in terms of how do we write valence Lewis dot diagrams? Yes, Mr. Alex?
So why does helium not have 8?
This is because helium has only two protons and 2 electrons. So because it has 2 electrons, you can't say there are 8. When itself has 2 electrons. But things like neon and argon, they have more. You have to check. I get it. This is 1 here. If you go check your periodic table, the atomic number is 1. Here the atomic number is 2, which tells you that there are only 2 electrons. Here the atomic number is 3. Here it's 4. Here it's 5. Here it's 6. Here it's 7. Here it's 8. Here it's 9. And here it's 10. Here it's 11. Do you remember sodium when I said sodium is 11 and 23? Where was it? Where did you think I got this 11 from? That 11 is coming from the atomic number, which is shown in the periodic table there. Okay, so the mass number for sodium is 23. I know it by head, but the others I don't know. I know calcium, the mass number I think it's 40, and then it has 20 electrons there. Then others there. I think lithium is 7. Then others, this one I think is also 1. I think here it's 4, right? But I think oxygen is 16. Chlorine is 35,5. Sulfur is 32. I'm not sure phosphorus. I'm not sure aluminium. So I'm not sure of the others. I think this one is 14, and then this one is 12. So I'm not sure of the mass numbers of others, but then you can just go check them there, guys. Okay, so but that is what is happening. When I should focus on how many valence electrons does it have, then you can draw the Lewis dot diagram. Clear? Yeah.
If we look at neon also has like 8 valence electrons, but then why does hydrogen have 2 compared to, or is that what you're explaining?
Why does what? Hydrogen have?
Neon has
Yeah.
8 valence electrons, and then helium also
has 2.
look at the
Okay.
also has 2.
Yes. So you are saying, why are we not saying neon is also 10?
Yes, sir.
Okay. This is because valence electrons are the electrons in the outermost energy level. Okay. Now it needs us to go back to Aufbau diagrams in grade 10. But you know what, guys? We'll continue these things. I think on Friday, we can have a session and talk about these things more. Okay, then we'll explain, because it's a lot, guys. It's a lot. You have to even show for compounds, so it's quite a lot. You can't but don't worry, we will talk about all of these things. You master them. But otherwise, so far I hope that we're together. If there is anything you missed, you can always go back to the recording to then check what we were saying there. But I will send a bit of a nice homework there just to check your understanding. Yeah, but otherwise, thank you so much for having me today. Have yourself a wonderful one.